How will the universe end? This is a question that people have thought about for thousands of years. Now that science has the information and resources to attempt a solution, scientists seem to know how the world will end. They predict that the sun will exhaust all of its fuel and become a red giant. The closest planets will be engulfed in its blaze of splendor as Earth is reduced to a lifeless burnt rock. That sounds eerie. Heat death is another unsettling hypothesis, the awful end of the universe. The theory behind the concept of heat death is that as entropy rises, it will eventually reach a catastrophic state, where thermodynamic energy transmission is impossible because the universe's temperature and energy content are uniform. Now, due to the faster expansion of the universe caused by dark energy, galaxies would disperse even more. As a result, astronomy would eventually reach a point when other galaxies are so far away that they break the line of sight of our observable universe, making it almost impossible to study them. At some point, all stars will exhaust their fuel and disintegrate into white dwarfs, neutron stars, or black holes. The bad news? The absence of interstellar dust clouds and concentrated gas nebula would prevent the formation of new celestial bodies. There would only be these stars' remnants left, and eventually, even they would merge with supermassive black holes. Since there would be no reaction or interaction, nothing would ever interact in the future. The universe would change into a lifeless, dismal place. The bad news is that our universe will eventually experience heat death, which cannot be avoided. It will, however, take a very, very long time to materialize. The problem can therefore be solved technologically in a technology society. The theoretical physicist Katie MACK opens her book about the end of the universe, a much more speculative idea, with its ominous scene. Because the only evidence cosmologists can investigate with telescopes is far away and relates to events that transpire in the distant past. They typically look backward. There is more conjecture involved in predicting potential futures from the motions of faraway stars and galaxies. The final doomsday scenario that Mack describes is extremely unlikely: vacuum decay. Due to instability in the field connected to the Higgs boson, a small bubble of real vacuum could emerge. If a black hole, for instance, dissipates in the incorrect way, that might happen. Such a bubble would grow at the speed of light, wiping out everything along the way until the universe was cancelled. Vacuum decay may have already started somewhere far away. We won't see it coming, but do not worry. Whatever it looks like, the end is probably still at least 200 billion years away. Astronomers once believed that the universe will continually expand and contract in an endless cycle of cosmic death and rebirth. The strongest evidence, however, leads to a distant Armageddon that is even more existentially terrifying than what is described in the Book of Revelation. Long after the destruction of Earth, the universe will continue to drift away until galaxy and star formation stop. Stars will slowly fade away, leaving the night skies completely dark. Black holes will consume all remaining matter until there is nothing left. The remaining signs of heat will eventually vanish. The universe is more likely to die from heat death rather than fire and brimstone. Astronomers call it the Big Freeze. The universe didn't always seem to be headed in this direction. Astronomers believe that the Milky Way galaxy was the entirety of the cosmos about a century ago. Our universe appeared to be static. It had consistently been the same and would continue to be so. But as Albert Einstein developed his ideas of relativity, he began to observe oddities. His mathematics suggested that the universe was growing or decreasing. To maintain the cosmos in a more desirable steady state, Einstein included a fudge factor, a cosmological constant. Nobel Prize-winning cosmologist John Mather, the lead scientist for NASA's James Webb Space Telescope, asserts that Albert Einstein was not acting foolishly. Rather, he was experiencing what astronomers were feeling. At about the same time, astronomers started to acknowledge that some of the hazy spiral-shaped nebulae they had been seeing through their telescopes were not clusters of stars in our galaxy. They were altogether other universes. And Edwin Hubble's careful measurements of their speeds revealed that these galaxies were in fact drifting away from our own. The expansion of the universe has been discovered by humanity. Rewinding that expansion eventually led to the discovery that the universe as we know it now was created 13.8 billion years ago in a violent Big Bang. After establishing its fundamentals, cosmology focused on the big question of how the universe will end. A universe that is expanding can end its existence in one of two ways. Either it will eventually collapse back on itself, or it will keep expanding indefinitely. Astronomers had to rewind the universe's development to determine which theory is correct. Furthermore, in 1922, Russian mathematician and physicist Alexander Friedmann created a well-known set of equations that came to be known as the Friedmann equations. These calculations demonstrated that our universe might either grow or contract rather than remain in a constant state, and that its fate is dictated by its density. If there was enough matter, gravity would eventually stop the universe from expanding and bring it crashing back inward. When astronomers totaled up all the matter in the known universe in the 1960s and 1970s, they concluded that there was enough mass for the universe to eventually collapse into an indefinitely dense state, or possibly even a massive black hole. Some believe that the universe will undergo yet another expansion known as the Big Bounce, after being compressed into an endlessly small point known as the Big Crunch. A notable advocate of the Big Crunch during the 1970s and 1980s was physicist John Wheeler, who is acknowledged for helping to develop the phrase black hole. It was an obvious outcome to him. Wheeler believed that each black hole served as an experimental model of the final condition of the cosmos at the time of the black hole revolution. Wheeler said that part of his love for Big Crunch came from looks. It was easy to picture. NASA Spitzer and WISE infrared observatories paired up to reveal this view of the region around the Milky Way supermassive black hole, Sagittarius A. The final repositories of matter in the cosmos are probably supermassive black holes, but even these will disappear eventually. Reality is unfortunately not often so relatable. According to Columbia University physicist Peter Voigt, just because we might find a cold, empty cosmos an undesirable future doesn't mean that's not where things are headed. In the late 1990s, two separate groups of scientists were surveying the distant universe, studying dying stars called Type Ia supernova, which serve as standard candles that help establish cosmic distances. They discovered that distant explosions were further away than they had anticipated and appeared to be darker. The expansion of the universe was accelerating rather than going down. The researchers had separately discovered dark energy, overturning accepted cosmological models. The unexpected finding of dark energy demonstrated how implausible it was for the universe to end in a big crunch. Gravity will never be powerful enough to counteract the inflationary effects of dark energy, even with all the stuff in the universe pulling inward. In other words, a big freeze is inevitable for the expanding universe. Today, scientists estimate that only 5% of the universe's mass is made up of normal matter. Dark energy makes up the remaining 69%, while dark matter makes up to 26%. It turns out that Einstein's cosmological constant, which is a key factor in averting a Big Crunch-style collapse, appears to be a real-world force derived from dark energy. All but the nearest galaxies will be too far away to detect in a few trillion years due to the expansion brought on by dark energy. Star creation will eventually stop as dense stellar remnants like white dwarfs and black holes lock up any leftover material, perhaps 100 trillion years from now. The last things in the universe, supermassive black holes, will completely dissipate through Hawking's radiation in around a Google year, which is definitely as a 1 followed by 100 zeros. Following this, the universe enters a period known as the Dark Era, during which matter is only a dim memory. According to the second rule of thermodynamics, entropy will keep rising in a system, like the universe, until it reaches a critical point. That implies that the universe will eventually arrive at a state in which all energy and consequently all heat are equally distributed. The temperature of the universe will be slightly above absolute zero. The demise of our universe will therefore probably resemble the opening of Genesis rather than the Book of Revelation. All will be empty and dark. Alright guys, that wraps up our video for today. If you enjoyed watching, please give us a thumbs up and hit the subscribe button for more.